Hello students, today we are going to discuss the Lee-Chatelier principle. Now what is the statement of Lee-Chatelier principle? So Lee-Chatelier principle states that the statement of Lee-Chatelier principle, if in a chemical reaction at equilibrium, if in a chemical reaction, if in a chemical reaction at equilibrium is subjected to is subjected to a change in temperature or pressure or concentration, the equilibrium shifts to that direction by which the effect of the change is minimized. So whole statement is, if in a chemical reaction at equilibrium is subjected to change in temperature or pressure or concentration, then the equilibrium shifts to that direction by which the effect of change is minimized. So in this way, to undo the effect of change, the equilibrium shift in that direction where the effect of change is minimized. In this way, firstly let us take the example of change in temperature. What happens when the change in temperature takes place in equilibrium? Suppose the reaction A plus B equilibrium forms C plus D. So this is a reaction. Now in this reaction, let's suppose the delta H of the reaction is equal to positive. Positive means the reaction is endothermic in the forward direction. So in this reaction, when the temperature is increased, when the temperature of the equilibrium reaction is increased, then the reaction proceeds in the forward direction, because when the temperature increases, the reaction proceeds in forward direction, and we know that the forward direction is endothermic. It is absorbing the heat in the forward direction. So on affecting temperature, its effect is minimized when the reaction proceeds in endothermic reaction direction. So reaction proceeds in the forward direction, and when temperature is decreased, so temperature is decreased, now it have to increase the temperature. So as we know that if the forward reaction is endothermic, then the backward reaction must be exothermic. It is compulsory that the backward reaction will be exothermic. So when temperature is decreased, the reaction proceeds in the backward direction. Now in the similar way, for the same reaction A plus B forming C plus D, if delta H is equal to negative in the forward direction, and now temperature is increased, in this way the reaction proceeds in the backward direction, because in the backward direction delta H is equal to positive. If delta H is negative in the forward direction, then delta H must be positive in the backward direction, So when temperature is increased, the reaction proceeds in the backward direction, because the backward reaction is endothermic and it absorbs the heat. So it undo the effect of change in temperature, and when temperature is increased. And in this reaction, when the temperature is decreased, the reaction proceeds in the forward direction, because the forward direction, here temperature, we are decreasing the temperature. So the reaction opposes it by releasing heat or by increasing its temperature. So reaction proceeds in the forward direction when temperature is decreased. Now secondly we have effect of pressure. Effect of pressure. Effect of pressure. What is the effect when the pressure is increased? Suppose for the reaction H2 plus I2 gas forming 2HI gas. In this reaction, delta N of the reaction is equal to 0 because 2 here, 2 minus here 1 I, 1 H2 forming 2HI. So 1 plus 1. Change in number of moles, gaseous number of moles, change in number of gaseous moles is equal to 0. That is delta Ng is equal to 0. 0 it is. So for the reaction delta Ng is equal to 0, for the delta Ng equal to 0, there is no effect of pressure, there is no effect of changing the pressure, and equilibrium is not affected. Equilibrium is not affected and reaction does not affect it when change in number of moles is equal to gaseous number of moles is equal to 0. Now when the gaseous number of moles is equal to negative, that is in this type of reaction, for example N2 plus 3H2 forming 2NH3. In this reaction we have 2 number of moles in the product side minus gaseous, it is also H2 is gaseous and H3 is also gaseous and 2 is also gaseous. So change in number of moles of gas, that is delta Ng, here it will be 2 minus 3 plus 1. Minus 3 plus 1 is equal to minus 2. Here delta Ng is equal to negative. So in this reaction when the pressure is increased, the reaction proceeds in the forward direction, because in the forward direction we see the number of moles is less, so pressure decreases in this direction. Number of moles is less, so less gas is produced, so pressure decreases. When pressure is increased externally, then the reaction proceeds in the forward direction, because in the forward direction the pressure is decreased. Now when pressure is decreased, then in this case the reaction proceeds in backward direction, because the pressure is decreasing. So reaction must want to increase its pressure. So in the backward direction we see number of moles, the 3 plus 4 is 3 plus 4, so 4 moles are there. So more pressure increases in this direction, 4 moles of gas is producing in the backward direction. So on decreasing pressure the reaction proceeds in the backward direction. In this way the effect of pressure in decrease is undue by the reaction by proceeding in the backward direction and increasing its pressure. Now third we have effect of addition of inert gas. Now making chart for addition of inert gas. This is the chart. So type of reaction here, and here effect of addition of inert gas. So first column, second column. If delta N of the reaction, delta Ng of the reaction is equal to 0, then there is no effect of adding inert gas. No effect at constant pressure or at constant volume. If inert gas is added, then there will be no effect when delta Ng is equal to 0. Now when delta Ng is equal to positive, change in number of moles of gas, so at constant pressure equilibrium is not affected, no effect. So at constant pressure, no effect. But when delta Ng is equal to positive at constant volume, the equilibrium shift to right. The equilibrium shift to right. Right means in the forward direction. The equilibrium, if delta Ng is equal to positive at constant volume, when inert gas is added, the equilibrium shift in the forward direction. The equilibrium shift in the forward direction. Now if delta Ng is equal to negative, so at constant pressure, equilibrium shift to left. Left means in the backward direction. Equilibrium shift to left in the backward direction. If delta Ng is equal to negative at constant pressure, the equilibrium shift to left, and at constant volume, no effect. Here at constant volume, no effect. So for delta Ng is equal to 0, if inert gas is added at constant pressure or volume, no effect at all. If delta Ng is positive, then at constant pressure, no effect, and at constant volume, equilibrium shift to right, that is in the forward direction. And if delta Ng is negative, then at constant pressure, the equilibrium shift to left, that is in the backward direction. And at delta Ng is equal to negative at constant volume, no effect is observed when the inert gas is added. So in this way, this is all chart for in addition of inert gas in equilibrium reaction at constant pressure and volume. Now